Now we're going to consider the other type of improper integral, and that's when you have a discontinuous integrand. So when your function is going to plus or minus infinity at some number a. So in other words, you've got vertical asymptote. So for example, we want to find the integral from -2 to 2 x over cube root x squared minus 4 dx. So here's a graph of that function. We can see our vertical asymptotes here at x equals -2 and x equals +2. Those are the zeros for the denominator node. And so our function goes up to infinity as x approaches -2 from the positive side, and down to minus infinity as x approaches +2 from the negative side. So, well, there's two trouble spots here, two vertical asymptotes. So the first thing that we'll do is we will break this integral up into two integrals, similar to what we did in the previous example. So this will be integral from -2 to 0 x over cube root x squared minus 4 dx plus the integral from 0 to 2 x over cube root x squared minus 4 dx. And then both of these pieces have to be finite to give a value for this integral. If one of those pieces is infinite, then we stop and we say that the integral diverges. So let's consider the integral from 0 to 2 first. So that's maybe a little bit easier to work with. So integral from 0 to 2 x over cube root x squared minus 4 dx. And then we're going to use a limit, as we did before. We replace our trouble spot with a limit. So instead of integrating from 0 all the way out to 2, because you've got this infinite vertical strip, you will integrate out to some number b. So we'll do integral from 0 to b of x over cube root x squared minus 4. And then we'll take a limit as that b approaches 2 from the minus side. So we're going to let this b get closer and closer to x equal 2 here, and we'll take more and more of that infinite vertical strip, and we see what happens in the limit. If we get a finite number, then that integral converges. So it looks like we need a u substitution here. I see a function and almost its derivative. So let's let u equal x squared minus 4. So our du is going to be 2x dx. Let's multiply by 2 here and then compensate outside the integral with a 1/2. So here's our du. And then in the denominator, we've got cube root of u, which is u to the 1/3. So now we've got limit. B is approaching 2 from the negative side. And we've got a 1/2 outside that integral. And then this will be integral, du on top, and u to the 1/3 in the denominator. And then we have to plug our limits of integration into our u substitution here. So if we plug 0 in, 0 squared minus 4, -4. And then plug x equal b in here, b squared minus 4 would be our upper limit. Like so. So u to the 1/3 in the denominator is u to the -1/3 in the numerator. So this is going to be a limit. B approaches 2 from the negative side, 1/2 integral -4 to b squared minus 4. And we are integrating u to the -1/3 power du. So that's now a power rule. So you raise your exponent by 1, divide by the new exponent. So limit b approaches 2 from the minus side. Got a 1/2. And then this will be negative 1/3 plus 3/3. So u to the 2/3. And then divide by 2/3 is multiply by 3/2. And we're going to evaluate that from negative 4 to b squared minus 4. Now the 3/2 we can factor out of the evaluation, distributive property. So this will be limit b is approaching 2 from the minus side. And we will have a 3/4 outside the evaluation. And then we've got u to the 2/3 power. So plug in the b squared minus 4. So it'll be b squared minus 4 to the 2/3 power minus negative 4 to the 2/3 power. So when we take a limit here, b is approaching 2. So b squared here approaches 4. This looks like 4 minus 4, 0. And, oh, that should be a 2/3 power, not a 2/4. But 0 to any power is 0. So this piece here is approaching 0. And then we've got a number here. So this will now be 3/4. And then 0 minus, and then negative 4 to the 2/3 power. That's second power cubed root. So second power, we'd square the negative 4 and get a 16, and then cubed root. So cube root of 16 negative. And so we multiply these, we'll get negative 3/4 cube root of 16. So that's this area here. And then by symmetry, the other area then, so integral from negative 2 to 0 of our x over cubed root x squared minus 4 dx then is going to be positive 3/4 cube root of 16, right, by symmetry. And so one is negative, one is positive. So this one is positive 3/4 cube root of 16. This one's negative 3/4 cube root of 16. So that's 3/4 cube root of 16 minus 3/4 cube root of 16. And those areas cancel and give us 0 for the whole integral. Now, again, if we would have gotten infinity here, we would stop and we just say the integral diverges. And that means you don't even have to evaluate the other one. Once one piece diverges, the whole integral diverges. And the reason is because if you have infinity here and minus infinity there, infinity minus infinity, that's an indeterminate form.